Hello students, this is Dr. John, your physics and math professor, coming to you with another parabola quiz style question. I've tried to pick questions that would be on a test or on a quiz for you, or most likely on an assignment as well. So here we have a suspension bridge. I've written the whole thing out for you on the bottom, just put a couple of details here. We have a suspension bridge attached with two piers or large posts at the end, and the shape of the bridge can be modeled roughly by this equation. H, the height of the bridge, is equal to 0.0025 times d minus 100 all squared minus 25, where h is the height of the bridge and d is the distance of the bridge from the one pier or the one post. And the cables are attached when h is equal to 0. Notice I've labeled it here. H is the height and d is this way along the bridge, 0, 0. So that's where the cables are attached here, and the same height over here. Here we have a couple of people walking on the bridge. How far apart are the towers? Well, what we want to do is we want to look at this equation here and we want to say, well, I would love to solve this for when h is equal to 0. That would help me to find the location of the different d here, of two different d's. But there's also a really, really easy way to do it. Let's look at that first. So here I've modeled this out for you here. Here's the river, the raging river below, and we have this bridge that sort of bends down like this. If you notice here, this is in vertex form. Remember, from your basic vertex form, we have a parabola. This is the x and the y axis. So we have a parabola that might go something like this. And the vertex form gives us this point. So if this is 1, 2, 3, 4, this is x equals 4, and let's say this is y is equal to 1. The vertex here would be x minus 4 squared plus 1. And it might have a number up here, 3, some stretch factor. I don't know what that is. So the vertex actually is given by this number here. That's as far as you over on the x, and then whether you go up or down here. So notice over here, this is in vertex form, which means the sort of the dip or the lowest point on the bridge is going to be 100 meters over and 25 meters down. I've already drawn that up for you here. The center point here is over 100. That's given by this, and down 25. This is your vertex that you're taking here. This is your x-axis, sort of. And this is your y-axis, starting right there. It's just a d and an h-axis in this case. So we know already the center point here is 100 meters. It's going to be another 100 meters here because the bridge is symmetric. It's free-floating. It'll be symmetric. So it's going to be 200 meters from here to here. If you're doing this on a test, you could really quickly write one-line explanation, and once you've done the sketch, you probably want to do the sketch first, and then do a one-line explanation, and you've probably done that. However, your teacher might want a little bit more of a mathematical explanation, so we're going to do that right over here. But what we'd like to do is see if we can solve this when h is equal to 0. So to do that, I'll just replace this right here with a 0. Now, how do we solve this? Well, we've got this 25. You always do the things furthest away from the variable. This is the variable. The one furthest away is this one. So let's add 25 to both sides. We add 25 over here, add 25 over here. 25, and then this over here becomes 0. We've got that. Now the next thing furthest from the variable is this thing. So we'll want to divide both sides by this. Divide both sides by 0.0025. Divide this by 0.0025. This term over here is going to become 1. We don't need that. So what is 25 divided by this? I'm going to work on that right here. 25 divided by 0.0025. Many of us would just punch this into our calculator. However, I want to encourage you to try to do them in your head, at least to get an estimate as quickly as possible, because that's going to, first of all, it's going to be good for your brain. It's going to really help you to develop your brain power. And also, it's going to help you to stop making and not make as many stupid mistakes with the calculator, which we all do. So take a look at this. There's a 25 here and a 25 here. So this obviously is a number that's much bigger than this one. How do we solve this? Well, we need to move the decimal over. How many points? Well, 1, 2, 3, 4. That will move the decimal over to there. And if we do the same thing here, the decimal previously is here. Let's move it over 1, 2, 3, 4. We fill in zeros and put the decimal there. So now we have a number here. I'll just erase all these little bumps here and erase this. We don't need this anymore. So now we have a number here, 25 or 250,000 over 25. Well, we can cancel this, make that a 1, with this, make this a 1, and we're left with 1 and 4 zeros, or 10,000. So all of this becomes 10,000. That looks like a reasonable answer. You can check it on your calculator if you want to. So I'm going to make this 10,000. Now we're moving closer and closer to our variable. Last thing, of course, we have this square. So we'll want to take the square root of both sides. Taking the square root of this and the square root of the squared just takes care of the squared, so we don't need that anymore. What's the square root of 10,000? Well, it's 100 times 100. Notice there's 4 zeros. There's 2 zeros for each 100. This is going to be 100 plus or minus. We should throw a plus and minus in there. Is equal to d minus 100. Now we can take this 100 to the other side, and we'll make this d is equal to 100. That's this 100 here, plus or minus 100. What the answers are, in this case, d is equal to 100 minus 100, 0, and d is equal to 200. So the location of these posts, the location where h is equal to 0, are right here, which we expected, and at 200, which is right over here. So the posts are 200 meters apart. It's just like we expected from a really simple analysis of the vertex form quadratic equation here. So I hope that helped, and if it did, I will see you in the next video. Bye-bye.